What you're about to see is an excellent interview with Mr. Rob Dodd, a project executive with Nabholz Corp., the construction company that's building a cross-laminated timber residence hall here in Fayetteville, Arkansas at the University of Arkansas. He's going to tell you all about collaboration. He's going to tell you about logistics. He's going to tell you about time management. He's going to tell you about how you can introduce a new product to a new area and make sure that you are compliant with codes and that you abide by the rules and that you meet your deadlines. He's also going to tell you that this is a very exciting program for Arkansas. Cross-laminated timber in PIERS, sure. Vancouver, Portland, Chicago, Minneapolis, absolutely. But Fayetteville, Arkansas? Yeah, that's right. We're going to do that too. And that interview starts right now. Good morning, Rob Dodd.
Good morning.
I'm Richard Massey with C+S Engineer Magazine, and I'm here with Rob Dodd. He is a project executive with one of the largest and most influential construction firms in the entire state of Arkansas and even in the surrounding states. And we're here to talk about a great program this morning with the cross-laminated timber is being used to construct a 200,000 square foot residence hall facility on the flagship university campus of the University of Arkansas. And so how you doing this morning, Mr. Dodd?
Doing well.
You had a good drive down from Rogers?
Sure was.
Good. Well, we're glad to have you in the offices, and we are shooting live at SWAG Group headquarters here in Fayetteville. We're in the conference room, and we're nice and cozy here. And, you know, let's not beat around the bush. Let's go ahead and get on into this. You're a project executive. You handle several big projects at the same time, one of which is the residence halls. And, you know, in terms of the educational value of this video, we wanted to ask you about some major objectives that Nabholz sees as crucial to the program and that would also be crucial for the viewers of this video to get their value out of it. And so I want to ask you about the collaboration that's required to do this program. Nabholz has got basic construction down pat. This is a little bit of a different animal. So how did you handle the collaborative aspect of this?
You have to be involved at a whole lot earlier stage than a typical project. We brought in the mass timber fabricator at the completion of 50% construction documents so that all the final detailing in the project could be designed around the connections that were going to be used on the project itself. You know, typically the design firm completes the design of connections and design elements, and then the project goes out you know, for bid, and adjustments have to be made at that point. Since we were doing mass timber and every fabricator has their own unique way of making these connections, you know, and designing all the elements that go in the building, it's very beneficial to bring them in at an earlier stage. Mm-hmm. And then as the construction documents are being finished, the designers can detail all those elements around the fabricator that's actually going to be supplying the project.
Okay, and in this case, the supplier is out of Europe, correct?
That's correct.
And so did they have representatives get on a jet and fly over?
Oh here? Yeah, they're over here on a regular basis. We also do a lot of you know, communication, obviously via email. There's a lot of computer modeling that goes in to these connections. We also have an in-house 3D modeler that's been engaged in this project, and he works with the Nabholz modelers
Okay.
and builds these models along with the design team, who's been building models on this project all along. So that's the collaboration between all the groups. A lot of when you think about wood's easy to work with. That's some of the appeal of working with wood. I mean, we all do that growing up.
Right.
Everybody's familiar with handling wood, and it's a friendly product. But on a mass timber project with the glue laminated support beams and post, as well as the panels, one of the advantages to timber is the speed at which it can be erected. It's lighter,
So
more nimble.
it is faster than.
It is faster. One of the things that makes it faster, now if you were to send out, if you something that we're all familiar with is is home building, from a residential standpoint, and we're used to the sticks being sent out
Right.
to the site and then field cut. They're all measured, they're cut, and cut to fit on site. Well, with mass timber, all the elements are fabricated to fit in the shop before they're shipped.
Right. So those are cut to fit in Austria.
That's correct.
Okay. Right.
With holes and penetrations
Okay.
and connections, they come out, you put it in place, and you're done. So you can imagine with all the pipe penetrations, the ductwork penetrations, the connections that have to go into this, that all those elements have to be precisely modeled, located, sized, and they have the equipment in the shops, the fabricator shops, wherever they are. In this case, in Austria, they have the equipment to make these penetrations in the large members, and so you have to know where these are going, and they have to be right. And these big wood elements are fabricated with zero tolerance, to fit precisely.
Okay.
And so that's the requirement for all the collaboration up front. Even on a conventional steel post and beam with concrete decks, there's collaboration and planning that's done up front. But even those, a lot of the penetrations are core drilled, through the slab, after placement. In this case, all the timber panels, they have the penetrations already, fabricated them in the shop.
Oh,
So
okay.
there's a lot more work on the front end, and it's a lot more time consuming. You have to get involved earlier, but the beauty is once they arrive on site and they're put in place, they're done. You're ready to go.
Oh, okay. Yeah, fantastic. So that front end collaboration is super key in terms of the CLT construction.
Right.
And so let's go ahead and get to a second. Your cost comparisons, your CLT versus your standard concrete and steel construction. What is the cost comparison there? They say it's cheaper, or more affordable, or what have you found?
No, right now actually there is a slight premium on the timber. Primarily due to the location. Logistics plays a large part in that. It costs a lot of money to ship product from wherever it's coming from, the Pacific Northwest, or in this case from Europe. There's a tremendous shipping cost involved in that. Now, we know that would be reduced some if it was more readily available, closer
Right.
and to the region, and you didn't have those shipping costs. An evidence of that, I took a trip to Vancouver with the Stadium Drive project team, and we went and visited several projects. And one thing that stood out to me was there was a couple of projects that we went in that were built entirely out of CLT, and the CLT was not evident when you went in the building. I mean, it was covered up with sheetrock. I mean, it looked like any building that you would ever go in. I mean, it was just used as a structure because it was a viable, cost-effective structural alternate. In this case, there is a little bit of a premium. Now, some of that premium is offset. It's one of those things you may pay a little bit more for it up front, for the material itself and to get it here. But if it saves time in installation, which we've done a lot of research on this, and and we're interested to see how it actually works out on our project. We're just getting ready to get into that. But what we've seen is a typical construction project with steel, post and beam, metal deck, concrete slab on a structure this size would take 18 to 20 weeks to erect. This one looks like it's going to be in the 12 to 15 week range.
Oh, okay, right.
So if you can save several weeks of install time, that translates into reduced overall construction time and
Right,
savings
and the
there.
building can start generating revenue earlier.
That's correct.
Yeah, okay.
Another key there too is that on a typical building, when you have the steel superstructure, that's all typically hidden. It's concealed with sheetrock ceilings or lay-in ceilings. I mean, everything's covered up, even some of the walls. But obviously, but in this case, a lot of especially the underside of the ceilings, when you lay these panels down and these floor panels that you put in place, the bottom side of them are going to be left exposed for the ceiling from underneath. Mm-hmm. So there's a tremendous amount of cost and time saved from not having to go in and install ceilings, to conceal your structure.
Okay. Good, and you're learning all these little tricks as you go with this program.
Yes.
I mean, yeah. Right. Okay. And let's get to another objective, and we're going to go through these objectives, but there's a lot more that we want to talk about this because this has a fascinating texture of different elements that go into all this. And you kind of mentioned this, CLT is a viable structural alternative. Obviously, you feel that it is, and obviously the industry does.
Right.
So, but, from your boots on the ground perspective and going through the front end planning, what did you get out of, evaluating this as a viable structural material? Right.
Well, overcoming the preconceived thoughts about wood.
Oh, okay.
There's a lot of fears about using wood as a structure. Obviously, exposure to the elements. The fear is if wood is exposed to elements, it has a tendency to decay and rot. If it's exposed to moisture, especially. So you have to know how to protect that and how to deal with it. The other thing is when people think of wood is that it burns, and
right, which is a controversy, or some people say it's a manufactured controversy that's in the industry. But go ahead and talk about that.
And from a stick frame perspective, that may be the case. Obviously, if you have smaller sized wood members. We refer to it as sticks. They do burn more easily. I mean, that it's almost like kindling, on a fire. You start it, that burns quicker than the bigger logs that you put on. The thing about mass timber, when you have these huge sections of timber, timber naturally, when it burns, it creates a char layer around the perimeter that protects itself. It slows the burn down and puts itself out. So. Overcoming that it was key, for having a timber structure on a project this scale. Obviously, that had to be conveyed to the local, fire, the local and state fire marshals. Those code issues had to be addressed, and those fears. So from a viable, if you're going to use timber as a viable structural alternative, you have to overcome those code issues, such as exposure to the elements, the fire, the testing, testing for wind loads, and any there's a lot of testing that's being done for earthquake loads, seismic protection, for these structures. And so it was key to have the design team come in all along the way at every step of the project and engage the local code officials.
Oh, hold on here. Y'all had to deal with the city of Fayetteville.
Oh yeah, city and state. Yeah, the city and state code officials, and they were involved in every one of the preliminary presentations. For where this project was going. what's the code issues, what's the concerns, here's how we're, the design team did a remarkable job of, addressing those code issues and concerns.
Now, did they have to change anything on the city code at Fayetteville?
No,
or?
there's been no, there's been no waivers, granted for that. Some of it was just explaining, the design team explaining the code sections that they were referencing.
Okay.
But all those had to be addressed. Now there were some comments from the code officials about certain elements in the building that they would want protected. For instance, when there was a discussion about using wood for the stair and elevator towers, the cores.
Okay.
There was talk about, because those are actually, in your 2-hour egress path from the building, and there was discussion about covering those elements with sheetrock, to protect, from fire.
Mm-hmm.
In the end, for maybe, that may have been a consideration for changing this, but I think it was more of a structural consideration for, for taking out some of the loads in the building, and from a cost perspective. The stair and elevator cores are cast in place concrete on this particular project.
So that was a change that was made.
For a variety of reasons, but the fact that change was made, that allowed us not to have to go into those areas of how those particular elements may or may not have had to been protected.
Right. So that was a compromise or a trade-off?
It was. I mean, and again, for a variety of reasons. I hate to say that it was all for code reasons. I mean, there could have been some code issues that came out of that had it continued down that path, but cost obviously entered into that. We did cost comparisons for, the steel bracing, conventional steel bracing around these stair cores, and for concrete, and even concrete block. And looked at all those different cost comparisons, and in the end, it was decided to go with concrete on the stair and elevator towers.
Okay, fair enough. Yeah, that's I can see you, Nabholz and Benderholz going to the Fayetteville City Council.
Yeah.
Talking to those guys about that, and I'm sure there are some big question marks that they had. So that's pretty cool that you guys were able to get in there and handle that local part, because local governments, state governments can shut down construction projects real quick.
They can, and the unknown is as big a part of that as any. Obviously this is the first of its kind around here. So there's a lot of questions and unknowns that are involved in that. So a lot of it is just the design team doing their legwork and presenting this to the code officials and letting them know, here's what we're planning to do, and here's how it satisfies the code. And that was a real key, all through this process is making that happen, and getting, doing the explaining and getting buy-in every step along the way. As opposed to going ahead and developing a project and then presenting it for code review and having a lot of kickback and having to make adjustments at that time. It was a lot of engagement at every step along the way on this one.
Right, and part of that is your firm, your company's experience in general, but also your experience doing a lot of work in this particular area.
Right.
And that pays huge dividends. As opposed to the project getting delayed for 6 months.
It does.
Because it gets kicked down to the state ledge or something like that.
Right.
So, yeah, good work on that. And Fayetteville can be difficult to build in. I mean, everyone knows that. And so let's go on your logistical challenges. So your shipping costs. Where are these things being shipped down the Rhine River and going out through the port at Rotterdam, or what?
This is that's fascinating. The exact names of the routes and paths I don't know, but Benderholz actually one of the ways that they're competitive is they actually source their own material. Now there's different fabricators have different ways of acquiring the materials that they use to make these panels.
Mm-hmm.
Benderholz actually sources them near the location where they fabricate.
Okay.
So they're sourced and fabricated in Austria, and they're shipped to a port in northern Italy.
Okay, hold on
Okay.
here. Shipped to Northern Italy.
right? And then they're going to be shipped over to the States in 114 containers. And
Out of Italy.
Out of Italy to Savannah, Georgia.
Okay, cool.
And then they're going to be put on rail in Savannah, Georgia, and shipped to Memphis, and then transferred to trucks and shipped to the job site at Stadium Drive. And then we have these shipments scheduled to arrive. You know, obviously we're not getting 114 containers in that area at one time. They're all phased by building when they're coming in, and we have 2-hour windows for unloading these containers and then getting them off the site. So that's the logistics challenge. You know, coming from Austria, you know, to 2-hour unload intervals
In Memphis.
Eventually at the Stadium Drive site.
Right.
We're going to have 2-hour unload windows there.
Okay.
You know, obviously there's not space. You know, it would be a logistical nightmare. You know, to have multiple trucks stacked up on Stadium Drive in Fayetteville. You know, with Fayetteville High School and the ball games at Bud Walton Arena, and then different times of the year. The events that are going to be happening there. There's a lot to plan on with just events, as well as just the everyday normal Fayetteville High School traffic and all the pedestrians around the site. So that's a logistical challenge. And then another one is actually when they're on site. After they're on site, the CLT panels are rather large. These floor panels. The ones that we're getting from Nabholz, they're called a 1.25 panel, and that's 1.25 meters.
1.25 meter panel.
Yeah, it's about 4'3" wide.
Right.
Okay, and they're between 7 and 7.5 inches thick.
Oh gosh. Okay.
So they're 5 layers. 5 layers of material that are cross-laminated to build up to about a 7.5 inch thickness. 4'3" wide, and they're right at 40 feet long.
Okay. Oh wow! So these are big.
They're big chunks. They're big chunks of final product. Now, when you have containers, full of that size product coming to your site, you either have to be ready to, pick and place.
Oh yeah.
Or you have to stage.
Okay.
And so we're having to work out. And even the glue lam pieces, the glue lam members on this project, which are the columns and the beams, they're 18 inches wide and 24 inches, 18 by 24, pieces of timber, huge pieces of timber. And when you have, multiple containers coming to your site with those size members, you have to have a place to put them. So, and so we're working that out. We have a spot across Stadium Drive.
Okay.
And this worked out really well for us too, because we planned on using that area for a staging area anyway, but we thought that would be our job site office location. As the job got closer, we found out there was an old house on Clinton Drive that the university was going to demolish, and they checked with us to see if we could use that, if that would be beneficial for us to use as a job office. So we took a look at it, and it's worked out great. So we're housing in a facility that will be demolished when we're finished with it, but that freed up a lot of space on Stadium Drive.
Oh right,
for us to store this material.
Great. So and we'll move on from that, but those are the things that I find interesting is the supply chain and the logistics. So you're going to have some muscle power down when those panels come in. I mean, you're going to have to on schedule. I mean, that's pretty tricky, as opposed to it's coming in. We'll be there. You got to be on it.
We got to be on it.
Oh, that's really cool.
And we're actually doing that ourselves. That's another intriguing piece of this. We're actually going to self-install.
Yeah, you're using all your own forces, right?
Using our own forces. Yeah. So that's that has its. That's going to have its challenges, and it's going to have its advantages. Obviously, the challenges, we're taking on something that not only we, have never done before,
right?
But I mean, nobody in this area has ever, done anything like this, certainly on this scale. So, there's a learning curve there that we've been doing, but you know, obviously the advantage is it's a lot easier to control your own forces than it is you know, someone else, and
Sure.
especially someone in this case, you know, those that we were looking at utilizing on this job were all from different parts of the country. You know,
Okay.
so you know, there's some challenges in bringing in you know, forces from other places too, and there's cost involved in that. But it's great that we you know, that we're going to be able to utilize that with forces that we already have.
Well, yeah, I mean, you've got to be excited about that. I
Yes.
mean, not outsourcing that to someone else, and then of course you'll have the experience when you're moving forward.
Right.
And so, and our last objective, this is the fifth, we only need 4, but you know, let's go for redundancy, right? It's always better to have more than have less. And you've kind of hinted at it, but introducing a new product to the region. So we've already talked about from the code standpoint and talking about the officialdom of it. But let's talk about, you know, your competitors, your friendly competitors, your subs, and all the different folks that you have to deal with to be a leading construction company. And you're doing CLT in Fayetteville, Arkansas.
Right.
So what's been that side of it in terms of introducing the new product?
Yeah, you know, it's always great to learn from others. There is a project, the library storage building.
Oh, right.
In the Art District, and it's a little bit different. The structure is a little bit different than what we're doing. It's a big box that has a lot of panels on the outside. Nabholz is actually supplying that project as well.
Okay.
That's from a construction company, Conrail, out of Arlington.
Okay.
And it's been helpful to you know, to strategize, you know, with them. And,
Okay.
you know, you know, and we'll do that together. We'll do that with other contractors as well. We're also getting ready to do one on a smaller scale for the 5th Street office renovation in Bentonville.
Okay.
And it's going to have some glue lam and CLT product on it as well. So as more and more people find out about it in this area, obviously we're going to have some experience in it, expertise, and,
Right.
and you know, hey, just like we've done with Conrail, we'll expect to do that, you know, with others.
Oh, yeah.
We've had the opportunity already with some wood symposiums and seminars, you know, questions from other design firms around the country about how we're dealing with things. So that's happening more and more. But you know, for actually introducing the product in this region, that's a new product. One thing that we're trying to do, a lot of the subcontractors, you mentioned subcontractors, a lot of them are going to be experiencing this for the first time.
Sure.
Now we all know, I mean, we've been doing a lot of research and going to other projects around the country to see how this actually, you know, installs and learn everything that we can. We can convey that all we want, you know, to the subcontractors that we're going to be working with. You know, hey, this is great. This is going to be easy to work with. You know, you guys need to think about this when you're, you know, we're just encouraging them to, you know, think about this when they're looking at the project. You know, you're not going to have the difficulties that you do sometimes with working with, you know, the hard materials like, you know, steel and concrete. Mm-hmm. This material is easier to work with. You're already going to have these penetrations in place. It's going to make your life easier. It's going to speed things up. However, we can say that all we want, but you know, and as it should be, you know, trust but verify. These,
Right.
You know,
Yeah.
they're going to have to see, you know, they're going to have to see this for themselves. You know, okay,
Right.
I'll believe it when I see it. At this point, you know, are the subcontractors really? Do they really know how to account for the efficiencies that may be involved in this product? They may, but as they do one and as they do another, you know, and as this becomes more and more common to work with this, then those efficiencies will be realized. And I think that's another thing too that will start, you know, driving this cost down, the cost comparison,
Right.
the difference. It'll drive it down and make it, you know, closer or even more efficient eventually than the conventional, you know, construction methods. But that's the challenge of introducing it, you know, into a new market, is just the unknown.
Yeah, you're right. Yeah, and you got to make people believe in it.
That's right.
Excellent, excellent. So let's kind of move into a few other things. This is I'm enjoying talking to you. You definitely have tons of experience in construction, so it's nice to talk to someone who's got the goods. And so you've kind of hinted at it again. Your answers are very comprehensive, but it seems like doing this big project at Fayetteville has obviously opened some doors for you guys. And so, do you plan on doing, I know you've talked about a couple of smaller programs, but do you envision your firm doing another, 250,000 square foot structure somewhere?
Yes,
Okay.
definitely. In fact, the supplier on this project, Nabholz, I was contacted in the last few weeks about partnering with them on some big projects in the Atlanta area.
Oh, wow.
And the timing of it, with what we're doing on Stadium Drive, with the resources that we have, did not make that viable for us at this time. But already doors like that are opening up, and as we do this and we become better at it and more knowledgeable from an installation standpoint, and we can start seeing the resources that are required and start, we always look when we're going to perform any work, you have to look at schedule, and how things overlap, and and it has to be a right fit, it has to be the right market. Again, at this time, it wasn't the right time or market to do this job in Atlanta, but those opportunities do exist. They're becoming more and more apparent every day, and I think it's just a matter of time. Ultimately, our goal is to set ourselves up as a force to not only build projects like this ourselves, and be an expert in managing these types of projects, but have the forces to do the installs for other contractors in other markets. So
Right. So that basically sounds like this could be an entirely new business line.
it could. And the cool thing about it too is that we're not having to hire a different skill set, to come in and do this job, and then wonder what you're going to do with that skill set once the job's complete. We're utilizing carpenters, skilled carpenters that we already have, that just need a leader that knows how this goes together. And so, if they're not actually on this job doing the timber install, tomorrow when this is done, they'll be using their carpenter skills, doing what they always do anyway.
Right. Good. Yeah. So you don't have to hire just for a particular program, and then send them home.
Right.
You can continue. Okay. And now I want to get into. I mentioned to this earlier before we started filming. I took down a couple of notes, and I think it's we're talking about London, Stockholm, Vancouver, Chicago, Portland, Minneapolis, Atlanta, Paris, and then over the next 15 years, Bordeaux, France wants to do 270,000 square feet of CLT every year, which I think the math goes over to 4 million square feet. So, but then you look at Fayetteville, Arkansas, which is a city of 70,000 people, and the greater metro is 500,000. So you're really punching above your weight here, and you're doing something that's really not just in big markets, but in very progressive markets. So talk about that. I mean, if you're out socially, if you're at a fundraiser, or if you're talking with your peers in other industries, I'm sure you know a lot of people in Northwest Arkansas. How is it talking to them about saying, hey, we're doing cross-laminated timber?
Yeah, I mean, how cool is that? This region, the projects that I just mentioned a minute ago. With, there's actually 3 prominent, projects, going right now with the library storage building, and Stadium Drive, and then the 5th Street office renovation. So, and to be, with that product in this market being mentioned in the places that you just did, you know, our team took a trip to Portland. The team on Stadium Drive.
Oh, you went to Portland?
Oh yeah, yeah.
Okay,
It's back in November when we were you know, really trying to decide if this was a project that we were going to install. We took the project team. There were 6 of us that went out, and there was a project, the First Tech corporate headquarters building,
right,
in Hillsboro, just outside of Portland.
right,
It's a project similar in size and very similar in construction to what we're doing at Stadium Drive, and we wanted to go see. I mean, what are they doing? You know,
right.
how are they doing? What, you know, what are some concerns? You know, what are some lessons that we can learn? You know, from this, and really to kind of validate, you know, our findings. You know, from projects that are being installed in these markets that you talked about. You know, in Vancouver and Portland and Minneapolis and all over.
Yeah.
So. You know, it is interesting when, you know, when you do talk locally about this product, you know, people are not familiar with it, and you know, and a lot of questions come up. Well, you know, well, why would you do that? And obviously there's reasons, you know, for the state of Arkansas that we do that we'll get into in a minute. But you know, the conversation always turns to exactly what you mentioned. Well, if you go to these places like, you know, Vancouver and Portland and you know, and a lot of the places in Europe, I mean, they're doing this all the time there.
Right.
And,
yeah.
And you know, and you know, it's when you see these projects, you know, not only are they you know, using an environmentally, you know, friendly
right.
product like the wood, you know, for whatever reasons they're doing it, and, you know, and a renewable resource. But you know, they're just beautiful, warm buildings. You know,
right.
we've been, you know, there's everybody has, you know, their thoughts about, you know, cabins and wood construction. I mean, there's a lot of wood, exposed wood, in the buildings that we've been doing at Crystal Bridges, you know, Crystal Bridges Museum and the Amazium.
Right.
You know, the glue laminated timbers and exposed timbers and the exposed wood decking. You know, everybody appreciates the you know, the beauty and the warmth, you know, of that wood product. So you know, to see it on a mass scale utilized for the structures is fascinating. But I do think it's remarkable that an area in you know, in the corner of Northwest Arkansas. And you know, in a way, it's almost natural. I mean, it's you know, the natural state and the beauty that, you know, the
sure.
beauty that's in Northwest
yeah.
Arkansas, and you know, and I think that, you know, it is a smaller market, you know, when you compare it to the places that you're talking about. But you know, there's just a, you know, a beautiful, you know, progressive, you know, nature to you know, this corner of the state. You know, it's not what it was a few years ago.
Well, yeah, looking at it from my perspective, I've lived here for 11 years in Northwest Arkansas. It makes sense to me, right, that not only would CLT go in to Fayetteville specifically, but right, that it would go in before the big tidal wave hits, because right, it still hasn't hit yet.
Right.
The wave is still building up out there, hasn't, you know, come to a crest. And to see Fayetteville getting in on the early side of that's really neat. So, right, and so a few more questions. You know, this is really good stuff. And you've gone over so much, but one of the things I wanted to talk about, you know, is for the people out there who are viewing this video, is, you know, Crystal Bridges Museum of American Art, Amazium. You did both of the new J.B. Hunt Tower, and you're doing the J.B. Hunt Tech Tower, Children's Hospital. You know, just some really big, crucial programs, and that's just the tip of the iceberg. But the main thing is Nabholz is not new to the game. Right. You've been doing big projects for a long time. Your resume is great. And so when it came to the RFP process, like to get this job, let's talk about that for a second. I mean, how was the competition?
I don't know how many. I think there was, you know, probably, you know, 10, 12, 13 that submitted. The university shortlisted. I think they shortlisted 5 or 6 firms to come in and and interview for this. Some of the firms I'm sure partnered with joint ventures or partnered up. I mean, it's,
there were some joint ventures.
There probably were. It's not everybody has the the size and capability to take on a project this large.
Right.
So that was helpful. That was helpful for us to do it. With without having to partner with anybody. When we are local. I mean, we're here. So
Right. Yeah.
But it was the interview. We did a lot of preparation. For this interview. We actually even before we were selected to go into the interview, we engaged a CLT consultant.
Okay. Right.
That was he worked with Structure Lam.
Okay.
Out of Portland and Vancouver.
Okay, so you're talking with those folks.
Oh yeah.
Okay.
We brought in. He was a professional engineer. That was an expert in mass timber, and we actually engaged him and to educate us on everything that we needed to know going into this, and included him as a consultant on our team. So that was vital. Of course, we have a lot of experience over the years on the university campus,
right,
and with housing.
Right.
And this is our client. It is the University of Arkansas, but our client on this project is housing. This is a dormitory,
right?
And it had to be sold to them. So we've got a lot of experience with housing, and we could talk to that. Just did a lot of legwork on preparing for this, and it was a lot of preparation for the interview, and we had a exhaustive interview at the university.
Oh, yeah.
They with facilities management and housing, and were able to present a lot of good information and get a lot of questions in return, and we were excited to be selected for it, and
sure.
But that was that was actually the RFP process for that project. We knew going into it that there was it hadn't been decided. A final decision had not been made at that time to use mass timber.
Right.
We knew we knew they were going to build a dormitory. We knew about how big it was going to be. The general scale of the project, but the design hadn't started yet. There was obviously a lot of cost comparisons to be done, and that was one of the charges that was given to us by the university is we're going to lean on you really hard to give us a lot of feedback on the cost comparisons and everything related to the steel and the wood, so that we can make a decision, a very informed decision about whether or not we are going to do this. But we knew there was a desire, and they wanted to. Obviously, we knew that because we started talking to the CLT consultant. It was a desire to do that, but it was not a decision that was made at the time that we interviewed.
Oh, okay. Wow. So it still could have turned out to be a concrete and steel building.
It could have, yes.
Oh.
Yeah. Even up until the schematic design phase.
Okay.
They were laying the building out, trying to position it on site and get the scale, and several different layouts were considered. And at that time, they were the design team was modeling all the different layouts to go either way. It depended on how the outcome came on the comparisons between the wood and steel.
So at the time of the interviews, it was still not determined.
It was not determined.
Wow. Okay. So Nabholz had a big hand in actually saying this is going to be CLT, or
we did, or
influence.
Actually providing solid research and and cost opinions.
Okay. Yeah.
That allowed the client to make an informed decision about where it was going to go.
Okay, right. So they were like, if we think it's going to be worth it and we think we can do it, we'll do it.
Right.
But if not, we're just going to go with more of your standard construction.
Right. There's a budget that they have to meet.
Right.
Obviously.
Yeah.
And so it had to be it had to work out for everybody. For the user group that was paying for it, it had to work out. But Obviously, there was a desire. There's a lot of reasons, and that the university, the School of Architecture, and even the state, there's a lot of interest in implementing wood and promoting a natural resource of the state.
Sure.
You know,
Yeah, and I don't, that's a different conversation, but apparently Arkansas will have an opportunity to get into that, but they're not there yet.
Right. The thing is, we've been, if you look at the map, and it's really quite remarkable. If you look at the Northwest, Pacific Northwest, where a lot of this comes from, in the states, and then up into Canada and in the Vancouver area, and you look at the amount of natural resource that's available there, and then you put a dot on Northwest Arkansas and look at all the natural timber resource that is available in our region of the country. There's a tremendous amount more natural resource available to us in Arkansas than there is in the Pacific Northwest.
Right.
They just haven't. The people that have to make the investments in the plants and the equipment to actually produce mass timber panels.
Right. This stuff has to be. This is not just clear cutting.
That's right.
Virgin old growth trees. This
Right.
is farm raised. It has to have certain criteria to meet.
Right.
And
And it takes a substantial investment, in the machinery,
Right.
The plants, the equipment to produce this. But in order for somebody to make a 10, 15, $20 million investment, to start, to invest in the equipment in the facilities to produce this, they've got to, have there's got to be a good reason for them to think that they're going to be able to sell the product.
oh yeah.
And,
right.
that's what a lot of this is about too. I mean, hey, they're putting up a 200,000 square foot facility in Fayetteville.
Right.
With mass timber, I mean, you need to get on board and start producing this so that you can provide it, because there's going to be more projects like this coming.
Sure. And two more quick questions about the RFP, and we'll get on. And this is a yes or no question. Did you think you were going to get the job?
We always think we're going to get a job when we have qualified teams and we prepare well. We don't get all of them, but we had a really good feeling when we went into this. We had the right team, we had the right approach, and yes, we felt pretty confident that we would get it, and would have been pretty disappointed if we didn't. Yeah.
Right. Okay. Yeah. Well, is there anything else you want to add? And with the caveat that we're going to go on site at some point in time, we're going to get our boots on and go down and check out this and film some more and get some more input. But I think we've got the sit-down office part done. But is there anything else you'd like to add?
The other thing, there's another intriguing element on this job that's not done all the time. It's more common than the mass timber, but it's still not something that we do on every job, and it's rammed aggregate piers.
Oh, hold on, that went past me pretty quick.
Rammed. And it's just like it sounds. I mean, they ram aggregate, into a pier shaft that they drill.
Ram aggregate piers.
Rammed aggregate piers.
Okay.
And it's part of the foundation design.
Okay.
And basically what it does, there's a lot of people are familiar with drilled piers, and where they actually drill a pier shaft and they fill it up with reinforcing steel and concrete.
Okay.
And a drill pier transfers load directly down to a higher capacity bearing material, like they drill it down to a hard shell, and it transfers load directly down vertically, to that material. A rammed aggregate pier acts differently in that instead of transferring load down to another substrate, it rams the aggregate into the surrounding soil. There's a whole lot of them. This project has over 1,100 rammed aggregate piers in it.
Oh.
They're closely spaced. They drill a hole 12 to 15 feet deep, fill it up with the aggregate, ram it in, and it engages into the surrounding soils. And basically what it does is it increases the bearing capacity of the soil that's there. And so the spread footings for the job that support the loads, the spread footings don't have to be as big, because the soil has a higher bearing capacity.
Oh, nice. So,
You know, if traditional, say the native soils that were there that you're burying in could had a bearing capacity of 3,000 pounds a square foot. Well, when you do the rammed aggregate piers, it increases that bearing capacity from 3,000 to say 10,000.
oh, okay.
And so the size of the footings, you know, the concrete footings that support the building, the size of the footings, say instead of a 10-foot square footing that would bear in 25 or 3,500 pounds per square foot material, now those footings instead of 10 by 10, they might be able to be 6 by 6. A lot smaller.
Okay.
So the cost of doing the rammed aggregate piers to increase the bearing capacity of the soil is you have to do analysis to make sure that it pays off to do this. But the analysis showed that the cost that would be spent to do the rammed aggregate piers was less than the cost of the footings that would have been required had the rammed aggregate piers not been put in place.
So for this project, it's more affordable than the drilled piers.
The drilled, that's right.
Okay.
Yep. And another thing that contributes to that too, obviously and they tie together. A wood, a timber structure is lighter, than a concrete or steel structure.
Right.
So that reduces some of the loads that have to be supported as well.
Fantastic. Well, and we're looking to finish up by fall of 2019, correct?
Right. Yep.
Yeah. Well,
students are coming for.
Yeah. Students are coming.
That's right.
Well, Rob, it's fantastic. This is a great interview. You've got a twinkle in your eye. You're excited about this program.
We are. Absolutely.
Yeah. Well, good. Well, I think we're going to wrap up for now, but we're going to get back on site here at some point in time soon. And
we can't wait to have you out there.
Yeah, I just wanted to say we really appreciate you coming down to SWAG Group today for this interview, and we've got a lot of dynamite stuff, and we're excited.
Great.
So thank you. All right.
Thank you.
All right. Okay, I am here with Mark Dilday, who is the project superintendent for the Stadium Drive Residence Halls here at the University of Arkansas. Mark, how you doing?
Good. How are you doing?
Good. I'll keep it short and sweet. There is an immense logistics problem to this site because it's an active site actually for the university, basketball games, events, Walmart shareholders. Tell us all about that.
Well, we have this 200,000 square foot structure being built right here, and the main lifeline for the University of Arkansas Bud Walton Arena is this ramp right here. So during all sports seasons, we have to allow access for them. We have to coordinate with their activities. Right now we have a little reprieve, and that's why we have these piles here. As we build the building and get all this cleared out, the athletics football season's around the corner. We'll have to have access for them to back their large vehicles down this ramp.
Yeah, and I heard something about 56 semi-trailers having to come through here.
Between more like 60.
Oh.
For a certain client they have that has a major meeting, organizational meeting here in the next month. We are preparing for that.
Okay, great. Well, so that's a pretty difficult ask to do, though, correct?
It is.
Have you ever had to do something like that before on a site?
Not to that scale, no.
Okay, well, thanks for telling us about that aspect. Good.
Welcome.
So, tell us again about these rammed aggregate piers and why they're so important for this project.
Well, the rammed aggregate piers are a new technology, at least for me. They are a gravel, compacted gravel. That's where the rammed aggregate. They drill a hole. These are approximately 30 to 35 foot deep. They drill a hole, and then they place gravel in 1 foot lifts and compact it. That equipment is gone, I show you. But it's large track hose. And they fill it up, and the inspectors test it as they come up. There's approximately 1,200 piers under this
1,200.
building. There's probably in this hole right here, which is a stair car elevator structure, there's probably 100+ piers there.
Wow. Was there ever a choice that could you have done this with a different type of pier system?
We could have done it with a concrete pier system, which is typical. It's what we've worked with before. I would say it's typical. I'm not sure the engineering or the reasoning, the logic behind using the gravel. I've never used it before. I don't know.
Do you like it?
It's probably, there's a lot of them, put it that way. It's a lot of drilling.
There's a lot of them. There's a lot of drilling. Great.
I don't know enough about them to tell you whether I like them or not. They were good to work with. The crew that came and put them in was really good to work with.
Right.
Being a specialized product, that crew is all over the country.
Okay.
So that's kind of a logistics nightmare and scheduling nightmare to get them here when I needed them here and get as much available for them as I could. As you can see, it's a very congested site.
Right. Okay, well, thank you, Mr. Dealday. I appreciate it.
Thank you.
You have a great day.
You too.
Hi, my name is Beth Brooks. I'm director of Civil and Structural Engineer magazine. The C+S team and I would personally like to thank Nabholz for partnering with us and sponsoring this webinar about the dynamic use of cross-laminated timber here at Stadium Drive Residence Halls on the campus of the University of Arkansas. Thank you so much, and we hope you enjoy the video.